Question number 11.8. Ortho and para nitrophenols are more acidic than phenol. Draw the resonance structures of the corresponding phenoxide ions. Now here, first of all, we have to understand that when the substance will be more acidic. So if it is a question of phenol, phenol is already acidic, and the reason is this OH bond. If it is more polar, that means the bonding pair of electron is more towards oxygen, then only it can give hydrogen easily, and we can say that it is a better acid. And second important point is, after giving H plus ion, the phenoxide ion or the anion which is left should be more stable. And in this case, this phenol is already stable because of the resonating structures. So, any electron withdrawing group like nitro group, and particularly at ortho and para position, if present in the phenyl or benzene ring, then this resonating structure will be more stable. So we have to remember that nitro group is actually electron withdrawing group. Any electron withdrawing group, if present at ortho and para position, will further increase the acidic properties of the phenol. So let us see how the phenoxide ion is more stable in case of phenol. So here is phenol. All the resonating structures you have to make stepwise and very carefully. Oxygen is negatively charged after giving proton, and phenoxide ion is formed. This electron is shifted in between oxygen and carbon, and this electron is forming the charge over this carbon. So by this, the structure which is formed is oxygen, this benzene ring, other bonds will remain same, that is no disturbance here, here, and here double bond is formed between oxygen, and the charge is appearing over here, and no double bond in between these two carbon atoms. After that, in the next step, what happens? In the next step, this electron pair is forming the bond in between these two carbon atoms, and this bond will be no more here, and it is forming charge at this carbon atom. So the next structure should be other points or other bonds we are not disturbing. Double bond will remain as such. Oxygen is here, and double bond is formed here, and charge appears here, and the double bond is here. Okay, after that, again in the next step, this charge is forming the double bond in between these two carbon atoms, and this double bond will be no more here, and it is making the charge at this carbon atom. So the next structure should be this is now double bond, and here it is the charge, and this double bond will remain same, and double bond O is not disturbed. And after that, this charge is coming over here, making the double bond, and this double bond is going back to oxygen and making the charge. So in the next step, we can make this double bond, and after that here double bond, and here double bond, and here single bond oxygen is left with the charge over here. This ortho and para This part was different. It is not the part of this phenoxide ion. And once this is coming back to here, these are all resonating structures. After that, we are coming to the first structure only. And because of these resonating structures, what happens? The phenoxide ion is more stable. And it will have this tendency to form the phenoxide ion by giving proton. And that is how the phenol is acidic. Now, what happens when the nitro group is present at ortho position? So, I said any electron withdrawing group will further increase the acidic property, and just see what happens when it is at ortho position, nitro group is present, which phenoxide ion will be more stable. So, we are keeping the same structure here. Oxygen is here, giving its proton and by that negatively charged. And one nitro group is present at ortho position. So this we can keep here. And after that, in the next step, this electron is coming back to here, and this is making the charge over here. Once you understood how to make the resonating structure, then it will be very easy. Just go step by step and you can make all the structures. So negative charge appears here, double bond will remain here, it is not disturbed. Even the nitro group will remain as such, and it is not disturbed at the ortho position in the second structure. But double bond is coming over here and oxygen will be here. After that, in the next step, this electron pair is shifting and forming the bond here, and this bond can not be here and making the charge. So this oxygen benzene ring is here, and double bond oxygen is not disturbed, and it is forming the double bond here. And this is the charge appears here. This double bond will remain same, and the nitrogen is again not disturbed till now. So it will remain same. In the next step, this charge is making the bond in between these two carbon atoms, and this bond is shifted to this here, and this bond is shifted here and making the charge here. So in the next structure, we can see that what happens. The NO2 group, which is electron withdrawing group, is also taking part in resonance and forming the double bond here. This double bond is also not disturbed yet, and double bond appears here also, and this double bond is shifted here, and nitrogen is here, and this is the single bond left with the oxygen, and this coordinate bond will remain as such, and it is making the charge here. In the next step, we are getting back the original compound, first structure. So this oxygen is making the double bond here, and this double bond is shifted here, and this double bond is going back to oxygen and forming the charge. So in the last structure, we can see that oxygen is now negative. This double bond is as such. This double bond is not disturbed, and this double bond is formed here, and nitrogen is here, and with this double bond is also here, and coordinate bond is not disturbed. So here you can see that this nitro group is further stabilizing by taking the electrons and making more resonating structure. So nitrobenzene, orthonitrophenol is more acidic as compared to this phenol. And now see what happens in case of para. In case of para again, the nitro group is at para position and directly it is also helping in resonating structures. So first one is double bond, and after that oxygen is here, and this is the phenoxide ion when nitrogen is at para position. This is the first phenoxide ion, para nitrophenoxide ion, and what are the resonating structures here? So first is electron is shifted between oxygen and carbon, and this electron pair will be no more here, and it is here. So making the charge. This nitrogen double bond is not disturbed, oxygen, and this is making charge. One double bond will remain here, one double bond here, and double bond appears here with this oxygen. Double bond is coming over here. And this double bond is actually shifted here. And this double bond is coming over here. So if this double bond is here, this double bond should not be here. So we have to remove this double bond. And after that, again, I have to select the pen. So single bond with the charge. In the next step, so we can have double bond, oxygen, and here one double bond appears, here one electron. Then in the next step, it is going back and forming the original structure. So oxygen is here, double bond is here. Other things are not disturbed and charge appears over here. So in all these resonating structures, we can see that this nitro group, which is electron withdrawing group, is further helping for the stabilization and for the resonating structures of phenoxide ion. That is why ortho and nitro phenols are more acidic as compared to phenol.